Hey, what's going on, guys? Today I want to talk a little bit about the internet. So the concept of the internet is really simple. About 40 years ago, there's this wizard who created this really big cloud. And then he sent the cloud up into the sky. The cloud emits these electrons and they can talk to our computers and give us the internet. Alright, if you're ready, let's talk about some internets. Okay, so the first thing you have to understand is what is a computer network. You guys probably have a basic understanding of what a computer network is, but let's just review and break it down. The lowest level of a computer network is called a LAN, L-A-N, and it stands for Local Area Network. And it usually goes across a building or maybe just a small room. LANs are made up of these things that we call Ethernet segments. An Ethernet segment is actually more than just that big fat wire sticking out of your computer right now. An Ethernet segment has two parts. The first part is a wire, an Ethernet wire. The second part is a hub. If you have a LAN set up in your room with 3 computers, each computer will connect via an Ethernet wire into a port on the hub. I drew a picture for you. This is a picture of 3 computers or hosts connected to one hub. It's so nice. So a hub is not a very smart device. All it does is copy its data that it receives on one port to every other port. Every single computer connected to a hub sees all the data. When a lot of people get into a room and create a LAN, this is also known as a LAN party. What if you want to connect multiple hubs together? If you want to connect multiple hubs together, you have to use these things called bridges. What bridges do is connect multiple Ethernet segments together to make a LAN. Multiple Ethernet segments are connected via bridges. So when multiple bridges are used to make LANs, the LANs can actually get pretty big. One LAN could span a whole building or perhaps one college campus. Also, bridges are a little smarter than hubs are. They don't broadcast the data everywhere. A bridge can intelligently forward data from one hub to another hub only when it needs to get there. So actually the picture was getting too complicated, so we can consolidate the picture with this huge big fat wire as the LAN, and it has different computers on the LAN. Alright, so we're almost to the internet. Don't get too excited. The first thing you have to know is that different LANs speak different languages. The LAN you set up at your weekly StarCraft party speaks a different language than the LAN that a company may use. Also, both of those LANs speak a different language than a wireless LAN, for example. How do different LANs communicate with each other when they're all speaking different languages? The answer is routers. So routers are actually pretty complicated devices, but all you need to know about them is that they allow LANs that speak different languages to communicate with each other. That's all you need to know. When you bring routers into the picture and you start connecting different types of LANs, this turns into a WAN, which is W-A-N, Wide Area Network. When we say wide area, all it means is it covers a large geographical location. Here's another nice picture I drew of LANs and WANs. You can see one LAN can connect to another LAN via a router, and those routers can actually form WANs and talk to other WANs. It's really complicated, but this is the last picture, I think, so check it out. So the most popular WAN today is the internet, and its geographical distance is worldwide. The internet is not the only WAN out there. There's another type of WAN called a MAN, M-A-N, which stands for Metropolitan Area Network. This is just a network that could span a city and help in city networking and communications. Right now, internet kind of means 2 things, so let's distinguish them. There's going to be a lowercase internet and an uppercase internet. The lowercase internet is very generic. All it means is an interconnected network. It's just a combo of LANs, WANs, MANs. Now when I say the uppercase internet, this is the internet as we know it. This is a little confusing, but the internet, or the capital letter internet, is just the most widely used and popular lowercase internet. Okay, so I don't want to say uppercase internet for the rest of the video, so from now on, when I say internet, I mean the internet, uppercase. Let's start talking about how the internet actually works. The core guts behind the internet is a thing called TCP/IP. This stands for Transmission Control Protocol / Internet. protocol. All this is a language or protocol. You can just consider it a communication standard or language. In order for your computer to be on the internet, it has to be able to speak and understand TCP/IP. TCP/IP protocol is very specific to the uppercase internet. It's not specific to generic internet. It's only the accepted and most widely used protocol for the internet. That's why it's so popular. Don't worry, you have TCP/IP, I have TCP/IP, your cell phone has it, we're all happy family. There's two main jobs of TCP/IP. Its first job is that there's a well-defined behavior of how TCP/IP sends data from one computer to the other computer. I'm not going to go into the details of how this data transmission works. Data sent to these things called packets or datagrams. The second part of TCP/IP is that it's able to uniquely identify your computer on the internet. The way your computer is identified on the internet is via this special number called an IP address. I'm sure you've seen these IP addresses before. It's some mumbo jumbo numbers with some dots. That number is pretty much your name on the internet. That's all it is. In reality, we never use these IP addresses to access people on the internet. I don't go into the web browser and start typing mumbo jumbo into the URL. That would be ridiculous. So for normal people like you and me, we use these things called domain names. All a domain name is just a human readable text that translates into an IP address. The thing on the right, the .com, is the first level domain name, and this is usually .com, .gov, .edu, you know. The word after the .com from the right is a second level domain name, and this is Google, Amazon, Harvard, or MIT. Second level domain names are always owned by individuals or companies, and sometimes you have to buy them if it's taken. Now to the left of the second level domain name is the third level domain name, and those names are defined by whoever owns the second level one. So in this example, it's maps.google.com. Com is first level, Google is second level, and then Google defines maps as their third level domain name. How do we know that maps.google.com goes to some special IP address somewhere to hit the Google Maps server? Who knows? So there's a huge database worldwide called DNS, Domain Naming System, which actually maps every single domain name on the entire internet into a particular IP address. Up until 1988, those domain names were actually kept in one single text file. Now it's like some big worldwide database. I mean, it could still be one text file sitting somewhere on a wizard's computer or something. I don't know. So the main power of the internet is that if you're connected to the internet, you can send and receive data from anyone else connected on the internet. And since literally the whole world is on this WAN or the internet, we can literally connect to anyone we want. We get through the internet via these things called ISPs or internet service providers. You don't have to know much about ISPs. There's only two things to know. One is that they give us access to the internet, and two is that they tell us to restart our modems when the internet breaks. So the internet really is two parts. It's all the wires that make up the LANs. Those LANs connect to routers and make WANs, and those WANs connect to other WANs and make big WANs. That's the internet. That's the physical portion of the internet. The second equally important part of the internet is the TCP/IP or communication language of the internet. Both of those things, the wires and the TCP/IP together, make the internet as we know it. So if anyone asks you what the internet is, you can just tell them it's like a big cloud that a wizard made. And then when they ask you how it works, you can just tell them to watch my video. Personally, I don't really like how all the companies and marketing advertise the internet as this cloud thing, because it's really not a cloud. When someone tells you that the information goes to the cloud, what they're really saying is that I don't want to explain what a network is to you, so I'll call it a cloud. I think it's BS, to be honest, because I don't know about this cloud business. Thanks for watching the video, guys. I hope you learned something. Please like the video if you enjoyed it, or drop me a comment. Also, check out my channel for some other computer videos if you're interested or you like this one. Catch you guys next time.